So today we got painful medium problem 138 copy list with random pointer. Basically we got a linked list with pointers to next node and then pointer to null or some random node, and we're supposed to return a deep copy of the list, so the pointers will return a new list and each pointer should point to the nodes in the new list, and we return head of the list. And there is 1000 nodes, they don't have unique values, they are in this range. So my idea is that when we get a random pointer, we need to know where it is. So here is my suggestion. First I iterate through this, and for each node I store a node in a hash map and then its index. Then when I go through, then I will make this random pointer stuff, right? And depending if it goes to null, I put -1, and otherwise if it goes to something, the random pointer from hash map, I know index, and then I can just copy it. Then I first build this, right, the second list, and then based on the indices I can do that. So I guess let's go for it. Who wants to click off? Click off. If you get the idea, go code it yourself and then take a look at the end of the video how I code it. So first we need to have like list 1 D, and we do it this way, and then node index. So node head while node index 0, and then L1 unique node index node next. Okay, so this way we get where they are, and I guess we can also make a competing list. So new head is, I don't know, node -1, who cares, and then new list nodes in this, right? So so I guess let's just do that. And then new list nodes append node with node val, and that's it. And then for node, for I in range len new list nodes, if I +1 len new list, yeah, this could be like okay. And then so then what we can do, new list nodes I next new list nodes I +1, right? And then return new list nodes 0, and then node head reverse index is this, or a random index, while node then random index append, and now we'll have L1 bits of node random if node random else -1 node next, so that we build the backwards index. And now if random index I dom equal -1, then new list nodes I random is equal to new list nodes random index I. There is almost got it. No way except that edge case I got it first time. That is ridiculous, bro. Okay, let's go. Do they use like dictionaries? O1 space? You kidding me? That's crazy. I knew it. That's recursive. Okay, so we start node. What the hell? Copy random list. I mean, I use O and memory. How you do this in O1, bro? Visited hash. So copy random list. If head in visited, okay. Create new node, okay, and then I mean, fair enough, I guess. Let's see. So old node is head, new node is this, and self-visited old node is new node, and iterate on linked list until all nodes are closed. So old node is old node next, new node next, and get clones of if node and node self-visited. And okay, so basically you just move the pointers. Okay. O1 space. Ooh, not sure. Is that really O1? Is it really O1, bro? Okay. And then what do you do with that? With linked list. A random is a random next. I mean, you can unweave pretty easily, I guess. That is crazy. Who comes up with this idea, bro? A head alt should be. So basically we create this. Okay, so you create that list, fair enough. And now the link pointer next run, okay, unweave the list. Damn, I mean, that's good. Why not? I mean, this whenever see you linked list problem and you don't immediately see the trick, then you know you are cooked. So okay, so iterate. First, let's iterate over the list and store copies of in a list. And for each node of the original list, store it with its index as a key value pair in a dictionary. Then iterate over the old list once again using the indexing dictionary to build a list of pointers to list of indices of the random pointer nodes or -1 over finally update pointers of the copied nodes based on the random index. First node in the list on where number of nodes, iterate through the list 3 times and do O1 work per node. On since theoretically, they use O1 if they directly build the answer, but that's kind of bra. We store the nodes and with their indices in a map, and we also store the random indexes. Okay, goodbye.